Okay, I know we spent a lot of days on section 5.3. This is the last one. Yay! So, anyhow, at first this doesn't look any different than any other of the ones we solved. Actually, it looks a little bit easier because I don't think we're going to have to factor. So, we're going to add the 1 over to the other side. We're going to divide out the 2. And we're pretty much solved. We just have to get some values. But what do we do with this 3 here? We actually can't do anything with the 3 right now. So don't think, oh, I have to divide out a 3. You can't do it yet because that 3 is locked away in this trig function. You can't get it out of there. The only way you can get it out of there is by actually evaluating this and figure out when is cosine equal to 1/2. So normally, I'm just going to do like a little sample problem over here on the other side so you can kind of see what I'm saying. So normally we would say, what if cosine of x equals 1/2? When is cosine equal to 1/2? We would say we would say x is equal to pi over 3 and 5 pi over 3. No problem. So if we were to write this in that other notation, we would say x is equal to, and this is from 0 to 2 pi, we would say x is equal to pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. And that's what we would do before. This over here is going to be a little bit different. So let's actually do that. So instead of saying x is equal to these, we're going to say 3t is equal to these. So 3t is equal to pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. But we haven't actually solved for t. We solved for 3t. So what we have to do in order to do this is actually divide the answers by 3 or multiply by 1/3. That might be a little bit easier in this case. And that's how we're going to get our answers. So we have to multiply. I'm going to split this up so we can do this separately. So 3t equals pi over 3 plus 2 pi n. I'm going to divide them by 3. And that's going to give me t equals pi over 9 plus 2 pi n over 3. Yeah, I know, it's a little bit weird, but that's how we have to do it. And we can actually apply that over here, so the other answer will actually be, if we take this answer and divide it by 3, we're going to get 5 pi over 9 plus 2 pi n over 3, once again, where n is an integer. Okay, so you're going to solve for these. Anytime you see in the original where it's not just a plain x or a plain y or a plain variable, there is an extra number there, we will have to do that in the end. So you don't try and get rid of that 3 in the beginning. You have to wait till you actually evaluate the trig function, and then you can divide out that 3 or multiply whatever it is. One more quick example, similar. I think you're going to know what to do on this one. So if you want to kind of pause this one and work along with me, it would be good. So 3 tangent x over 2 plus 3 equals 0. All right, 2 easy steps to solve this. I'm going to subtract 3. I'm going to divide by 3. And negative 3 divided by 3 is going to be negative 1. So, simple 2-step equation. That's not an issue. We can get to this point. Now, same thing up above. We cannot get rid of this 2 in its current form. We have to actually evaluate this tangent function and figure out what it is, and then get rid of that 2 after we're done. So, when is tangent equal to negative 1? Let's see, tangent is equal to -1 at 3 pi over 4. And remember, we're looking in just that interval from 0 to 2 pi. So from 0 to 2 pi, not 0 to 2 pi, excuse me, just from 0 to pi on this interval, x over 2 is going to equal 3 pi over 4. Okay, so that's just on the interval. So let's now look at this, think of this as far as infinite solutions. We would know that x over 2 is equal to 3 pi over 4 plus, this is the tangent function, so instead of 2 pi, we're just going to do pi n. Now we have to continue solving for x, so to undo the division of 2, we're going to multiply by 2, but we have to multiply the entire thing by 2. So this and this will get a times 2. So I can show that for you. Oops. X is equal to 6 pi over 4 plus 2 pi n, and that can be reduced. 3 pi over 4 plus 2 pi n, where n is an integer. Okay, so whenever you see there is a number with the variable in the argument of the trig function, you do not get rid of that number until the very end. You solve just like normal, and then you do that in the very last step. You either multiply or divide depending on, you have to do the opposite, of course. Okay, so the last couple examples here for you. And that would be page 376. I have 3 of them for you today. That will be 33, 35, and 37. And we will finally move on to another section after this. So continue solving. If you have any questions on solving any of these equations, let me know. And then submit them when you're done. Thank you.